Okay, in this video lesson, what we're going to do is focus on the development of a game state management system with Evil Monkeys.
Oh yeah.
By the time we get to the end of this video, we will have a game that feels like a game. We're going to be able to run around and shoot evil monkeys like we can now, but over on the right-hand side of our GUI, we'll be able to see how many lives we currently have, how many enemies are in the level, and what level we're on. And the reason that's important is because when we finish our levels, we want to be able to advance to the next level,
Right.
which is really cool. We're also going to go ahead and set up the base foundation, if you will, for a lesson that's coming up in the future, where we'll be able to import our own levels off of files. Okay, so that when we get into the level editor portion of this VTM and we design our own levels, we can then bring those in as opposed to randomly generating
those levels.
Exactly. Right. So anyways, before we start talking about the objectives, at least a little bit closer than the overview, game state management. That's pretty important. When you say, Joel?
It's very, very important because typically you have, if you think about a game, you have different states that you have. At the very beginning, before you even start a game, you can kind of have the null state, where you don't really have anything going on. And when you start a game, the game is running. If you want to have, let's say, you shoot your missiles and you run out of missiles, that's another state where you don't have any missiles. The no state missile, no missiles.
The game's over.
The game's over. All sorts of different states, and that kind of helps game logic a lot, actually.
Exactly. And let's use a game like Unreal Tournament.
Okay.
I mean, they use state management, which is extremely important. And this is really cool. This is a really good example. With, let's say you were doing a weapon as a mod for Unreal Tournament. Well, when your weapon fires, let's say it has a spin-up phase before it starts actually firing any projectiles out of it, they use states to say, all right, we're in the anim spin-up.
Right.
So we can't begin firing anything yet because we're in this state and we haven't completed the state.
Exactly.
Once the state's finished, then we can advance to perhaps the primary fire state. And what's nice is at any given point, we can check the state that we're in to make sure we don't, I mean, you don't want the weapon to start spinning down if the player hasn't let go of the fire button or something like that. So states become important, not just in Evil Monkeys, but I mean, this has really become a common practice in game development.
Design.
Exactly. So we thought it would be really cool to introduce you guys to it and implement it in Evil Monkeys.
Yeah, and it will make it so that if you want to add new features to Evil Monkeys, it's very, very simple. Add a new state, say this is something else that happens.
That's right.
And it makes a whole lot more sense.
And not only state management, that's not the only thing we're going to be looking at in this lesson. By the time we get to the end, we're going to be enhancing the game logic so that we can advance levels and update our information, etc.
Right.
So basically what's going to go on, we'll start out by declaring variables and constants needed for state management, just some enums that we're going to set up. From there, prototype necessary functions. We've got 3 new functions that we're going to be adding. We've got the start new level, update view, and update game.
Right.
And you want to talk about what each of these are going to do briefly?
Yeah, sure. Start new level. When you go to File, New, it's going to call this function, which basically sets everything up. It's the same thing we do in the constructor now.
Right.
Well, pretty much. It kind of generalizes a little bit. But we're also going to be using this when we advance to a new level. So we're going to say start new level. It's going to delete the old level, create the new level, etc. Update view, if you remember from the previous lesson, we're kind of calling the same things. We're drawing the bitmap from the back buffer onto the screen so people can see it. We're going to kind of localize all that into one function and just call update view.
Okay.
And update view is going to get a little bit more complicated in later lessons when we add stretching and stuff like that. So it's good to localize everything into one function. Update game, that's pretty much where most of the state management is going to come into play. We're going to check which state we're at. Is the game supposed to be over now? Should we advance a new level? All of that's going to happen in update game. So that's pretty much it.
Okay, cool. And then anyway, so we'll implement the basic state management. We'll get all these guys up and running and test the game at that point.
Right.
So we should be able to at least start a new game, run around, shoot some guys, end the story. We don't have any real game logic in there to say, okay, all monsters are dead, let's advance to the next game.
Yep, that's all inside of update game.
And then that's going to come down here to enhancing the game logic. So as Joel just said, we're going to update the update game, or we're going to add to the update game functionality, go ahead and define it. And this will give us the ability to advance our levels, to update information like how many lives we have, what level we're on, etc.
Exactly.
And by the time we get to the end, we'll have a playable game. Okay, so that's the objective of this lesson. As I said in the last lesson, we're just going to try to take it easy, relax, and
we're going to chill out.
We're going to chill out and explain it to you just as calmly as we possibly can.
Yep.
So let's go ahead and head over to the app frame header and do some typing.
Ooh, fun. So over in here,
set up our enums first.
The first thing we're going to do is come over to here, our enum game state. This is the very important one. And as we said before, in later lessons, we'll be adding different states to this. But to start out, we'll have a state null. We'll just equate that to 0.
Sure.
Not
Why
400.
Why not 400?
Yeah. I knew that was coming. And then another game state will be game in progress. This is after you press new game, we know that the game is now in progress.
That's right.
We also have a state where the game is over. So when the game is over, we're going to set it to that. And if the player has won the game, which in this case is not going to happen yet, right? Because we're going to randomly generate the levels. We don't really say this is the end. We just keeps on going and going and going. So let's go down to here, and let's declare these 3 functions that we have here. So under the private section, we're going to declare our bool start new level, as we were discussing before. And it has one and only one argument, the level type that we want to create a new one of.
Right.
And this is going to, in this case, we just want to have a random new level, right?
Right.
But in the future, we may want to load a package, etc. So
right, be able to load our own custom levels.
Exactly. So in this case, we're going to create another enum called level type, and we'll just pass that into it. And let's kind of go up
do that, yeah.
and add this into here. So we have our enum level type. And for now, we only have one thing inside of here, and that's the random new level.
But remember, later on, we can now come back in here and easily add new level types.
Exactly. So we can say that, and I don't know if this may confuse some people. The fact that these two are zeros is perfectly okay because they're comparing 2 separate things.
Right, and not only that, here's a good place if you want to point out kind of a tip about enum and naming.
Oh, that's a good thing. If we go over to the class view right here, this is really nice to get just from a class kind of standpoint, not by file based.
Right.
So we have our app frame. It shows all our functions, our private variables, etc. But it also shows our enumerations as well. So down here we have game state, ID list. A lot of people do not specify names here, so they just kind of leave this empty. But which is fine. But look, just a second ago, game state was here. Now it's turned into an unnamed.
Yeah.
And that just, if you're using the class view, that makes it very difficult to see what's going on.
Right, and we prefer not to be messy, so it's just a good idea to add the name in.
Right. So if we add it back, it goes back to game state.
That's nice.
Yeah, it's very nice. So yeah, that's a good tip. Thank you. Another thing, let's go ahead and add our update view function. So we have our update view function.
And just send it void because it doesn't need to give us anything back.
Right.
I mean, it doesn't
we don't
take
need to pass
anything.
anything.
Yeah, exactly.
And we'll also...
My brain's thinking in reverse.
No worries.
An update game as well. Again, we don't need to send any information. His job is just to simply update the game.
Exactly. So we have these functions. The other variables that we need to add, as we were talking about before, we need to store what level we're currently at.
Right.
So we're going to create an int current level. And another thing we need is the game state that we're currently in. So we'll create a game state, and we'll just call it game state. Seems to make a lot of sense.
It sure does.
So that's pretty much all we do.
Did you want to, while we're in here, go ahead and just set up the destructor as well?
Yeah, we might as well do that.
Because we need to do some cleanup.
Right, we could have added this in a previous lesson, but it seems like a good place to add it right now. For sure. So let's just add a destructor here. And otherwise, if we go back into context here, that pretty much covers the first 2 steps here.
Yeah.
So that's cool. Now we can start implementing this. Yeah, almost halfway.
Halfway.
So let's go back over to here, and let's go to our Solution Explorer here, and just go to our appframe.cpp.
And which step are we on now?
We're on step
short-term memory.
So
implement the basic state management system. Okay.
And this is where we start actually implementing stuff. This is where all the typing is going to start happening. So if we come over to back to Evil Monkeys, let's first initialize some variables. Okay. This is very important because we're going to be testing, whether or not a player has been created yet.
The level, the back buffer.
And it doesn't automatically set everything to a state of null, if you will. So we're going to say player equals null, make sure that it knows we have no player, and make sure it has no level. And if we just go down now, ding, 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 we're going to be replacing all of this. This is initialization code. This is the stuff that we're going to put inside of start new level.
Right.
Let's just leave this here for a second, though.
Because think about it. When our GUI launches, when we launch the game, just the whole application, we don't want a game to automatically start.
Right.
It's going to be up to the user to go up to the menu and click File, New, or File, Load.
Right.
Which will come later. So we don't need this in the constructor. That would not make sense.
No, not at all. So what we want to do is start out by saying game state. What does the game state equal? Okay. Well, nothing has happened yet, right?
Right.
So it only makes sense to call this state null.
Mm-hmm.
So that's cool. Now what we want to do is actually go to the onNew function and begin creating the new level, right? So
and just a reminder, if you don't mind, Joel,
yeah,
I'll
no
throw
problem.
this in real quick. We set these up a while back. In fact, all the way back in, I think, the second lesson where we created the GUI. So these have just been empty functions, just sitting there for the menu, and now Joel's just going to add the functionality in for onNew and shortly for exit.
Exactly. So in onNew, what do we want to do? We want to first make sure that if a current game is being played, let's stop it.
That's
so
right.
we stop the timer. Oh, well, actually, even before that, let's first set the game state. Well, actually, let me think. Oh, I'm sorry. I'm looking at my notes and getting myself confused.
That's all good.
So if I go down to here.
Because since this is all going to take place in this function, the only thing we're going to want to do with game state is tell it that it's in progress, because we've said create a new game.
That's right.
But we'll do that by the end of this function.
So we also want to clean up our variables first, right?
Right.
So if there's a current player,
let's kill
delete
them
the
out.
player.
That's right.
And then we'll create a new player, which we're going to do exactly like we did up here. So let's just copy and paste this line. Just right in there. And let's start a new level. Remember, the new level function basically creates a new level, deletes the old one, and sets everything up for us. And we want to create a random new level. And now, let's add some enemies into it, which again is exactly
so again,
like here.
you might want to just cut and paste all that in there, and we'll just modify as need be.
Okay, let's see. So all of this stuff right here, just cut it out. And let me just paste it in here. So, and some of this is going to be put in, like,
in
this one right
areas,
here.
Right.
We're just going to kind of delete him out. And we'll delete this line because we already know what he has there. Actually, we almost have everything we need for this function here. So we add the enemies. We also need to set the current level equal to 1 because we know that this is the beginning.
The very first level. It's a new game.
And what else do we want to do?
Well, we need a game state set.
Yep.
We need to know that at this point, the game is in progress. Yeah.
And finally, what do we want to do? We want to start the game.
Better have that timer running.
So, timer, start.
So it's just simply set it up so now that the game logic will be able to tell that the game is in progress, and we fired the timer.
That's right. So to get this kind of working, let's go ahead and implement our start new level function.
Okay.
So let's go to the very bottom. All of these functions up here are event handling functions, so it's kind of nice to split your source file into two separate sections, if you will, where you have the event handling functions on the top and the other functions on the bottom. At least that's the way I manage it.
Yeah.
So on the bottom here, let's just create our which is the one we're creating now? The start new level.
That's right.
So let's go to bool app frame start new level. And of course, it's going to be a level type of type. And the first thing we're going to do is, again, clean up our old variables.
That's right. If there's a level out there, we need to go ahead and get rid of it.
So if there is a level, delete it.
And if there's a back buffer, that means we've got information about what an old level looked like. Let's go ahead and kill all that out.
Right. And the reason we're doing this, I mean, you could say, well, if it's the same size, we don't really need to delete it.
Exactly.
But the problem is, in the future, we're going to implement package loading, and the levels could be different sizes.
That's right. And speaking of package loading, at this point, since we're starting a new level, it might be a good idea to check what kind of level are we starting here. And,
right.
And so I guess we could just go ahead and do a switch and base it off the type that we're receiving in, or since the function receives in the level type.
Right. And so we can say, if the case is
a random new level.
What do we want to do? And let me just clean this up a little bit.
Let's go ahead and create a new level.
So exactly like we did above again. Let me just scroll back up here so you guys can see. Oh, actually, I cut it out. I'm sorry. So let me paste this in here. And as you can see, I still have some of the code that we're going to need in here, but not for exactly in here. So we have our level equals new level. And then we're going to pass it our draw
area.
Our draw area, which is our draw engine. And we're going to pass it level underscore x and level underscore y, which, remember, these are the constants we defined before. And let me just cut this out a little bit. Sorry there. Now, what do we need to do? We need to create a new back buffer, right?
Right.
That is going to be where we're going to draw our level. So if we go all the way back up to here, back in our constructor, you'll notice that we create our new back buffer. And we also need to set the draw engine to refer to that new back buffer. Since we're going to delete it and put it back in, the draw engine needs to be updated.
Right.
So let's kind of just take both of these lines.
And cut them out of there because they don't need to be in the constructor anymore.
Exactly. And put them down here. So we create our new back buffer, and we say draw engine now refer to this new back buffer.
Except we need to modify this just a little bit.
Just to kind of make it a little bit more general.
Right. Well, we have a level now.
We do have a level.
And the level does have a member function for getting the width and getting the height.
So we can just say level get width, and right here, level get height. Simple enough.
That's right, because the level underscore X and level underscore Y was cool for doing a random level.
Right.
But by the time we get outside that switch, who knows what type we chose? I mean...
Right, if we had, instead of random new levels, say load package...
Right, then it would have been whatever the level designer created, and at that point we don't want to use level underscore X and underscore Y, because those numbers would have been irrelevant. It would have been whatever the designer created in the package. So by using the member function get width and get height, we're for sure to get that correct.
The right size. So let's put that in here as well, so that the draw engine knows which one to use.
Mm-hmm.
So level.getHeight, perfect. And now let's see, what else do we need to do? We need to add the player into the level. So we add the player into the level. Then we're going to draw the level out, and we also need to update the player so that he's looking at the correct level. So the player is now supposed to be in this new level we've created. So simply like that. And let's update the player. So update. And let's just delete these two out.
And since this was set up as a bool...
Yeah, we're going to just return true for now. For now. In the future, we'll actually utilize the return value in a good way. But right now, we'll just return true and say, consider this as the function has
successfully created a random level.
That's exactly. Right. So if we go back to context real quick here, there's one other thing we're going to create before we test the game, and that's going to be the update view function. And this is going to be a very, very, very simple function.
Yeah.
We're just going to come down to the bottom here and create our void app frame. And we're just going to pass it a void. Inside of here, we're going to create our... Actually, let me just go up to one of these old ones.
Yep.
Like onKey. As you can see, the onTimer, the onKey, that will do exactly the same thing. No point in doing that. So let's just cut these guys out here, go all the way to the bottom, paste him in. We are going to have to be a little bit careful, though, to make sure that it doesn't try to update the view if there's no back buffer.
That's right.
Because at this point, we're not just... it doesn't start out with the game in place. I mean,
no, there is no back buffer because we've set it to null.
Right.
And the game's not in progress. It's at null as well.
Right. So if you try to draw a null bitmap, it's not going to be happy.
No, not at all.
So what we need to do is make sure that if back buffer, so if it does in fact exist, and game state is equal to state game.
Yeah. State game in progress.
Progress.
Yeah.
Then we're going to print it out. And now instead of doing what we did up here with onKey, let's go ahead and just call update view. But we're also going to need to check before we actually update the key press.
Might want to put a terminator in there too.
Yeah, thank you.
Yeah.
Let's make sure that it is actually in game progress.
Okay.
So let's say if game state equals game state
game in progress.
State game in progress so long, then print it out, and then we want to update the view. So update that, and then update the view.
Right.
So that's all we need to do there. And right here, we'll do the exact same thing, but we can pretty much assume that at this point we're definitely playing a game, right? Because otherwise the timer
should be shut down if we're not playing a game.
That's right. So all we need to do is delete this guy out and say right in here. Let's go ahead and say if game state. Just make sure that
this is just being clean.
Just being clean, just in case. If game
it's in
state,
progress, let's go ahead
and basically just level update, and just pass that.
Okay.
And then we're also going to need to update the view as well. And we're going to change this function around in just a bit so that we actually utilize the update game function.
Right.
But right now we're just kind of hard coding it in here, and then we'll change it to make it a little bit better in a second here. On paint, we'll do exactly the same thing. We do want to clear it to black, but we'll call update view, and it will handle actually drawing the correct stuff. So with that, let's also implement the OnExit function just real quick.
Sure.
Just put in a close, as we did in the previous lesson, VTM or wherever it was. Look at that. I was about to say, I don't have any errors. We didn't create the destructor yet.
And let's go ahead and do that because it really is just a matter of setting our game state, stopping our timer, killing the timer, player, and level.
That's right. So let me just come over to here.
I'll walk you through it. We can do it.
Okay.
So game state equals state underscore null. So we'll basically take the game state and say there is no game. Then let's stop our timer before killing it out. Again, just being clean here.
Right.
And then let's delete our mtimer. And then let's just simply check if there is a player. Let's go ahead and delete the player. Yeah, we'll clean up our memory here. And if there's a level, we'll clean up our level. Rock on.
So that's all there is to it.
I'm liking it.
I'm liking it too. So let's link this. In fact, just for safety's sake, let's rebuild the solution. Make sure everything is pointing to the correct locations. Right. Just give it a second. And since we're using precompiled headers, it is very, very fast.
And it likes you very,
and it
very
likes
much.
me. So let's run this. And we start out with this elongated panoramic view.
With, of course, no game.
No game.
We now have to go to File, New.
So let's go to File, New, and check it out.
Up, and here they come. Run for your life!
And at this point, the game states are there, but if we kill everyone, check it out.
He's smarter than you.
Wow.
He's smarter than you.
That's not fair. I just want to show that.
That's awesome. Oh.
Okay, so at this point, I killed everyone, but look at this. I'm still running around the level.
Right.
No game state.
We need to enhance our logic just a little bit, the game logic itself.
Right. The only game state we have is, well, the game is in progress or the game is not in progress.
That's right.
So let's go ahead and exit this out.
No! Run it one more time just to show the file exit works just great.
Okay. We can go to File.
And exit.
Exit.
There you go.
Well, let's go back to context for a minute, just so you can see where we are. We've just created this function, the update view function. We have tested the game, and it works. So now we're up to the last and final step, where we create... We basically enhance the game logic so that it allows us to advance levels,
and
update the
information on the side.
So that we make sure all of that stuff works. So let's go ahead and go back over into our source code here. Go to app frame, and again, let's just add this to the very bottom. This is kind of my coding style, so if you don't like it,
do your own
style. So let's create an update game, and again, I did create these as private functions because we don't really want anyone outside to access these. These are something that we use internally. So in an update game, what do we want to do? Well, the side information. That's something we want to update. So let's create a WX string, and we'll just call this info lives. And we'll equate that to lives. Remember, in the constructor, we set it to lives.
But now we're going to concatenate.
Concatenate, very nice.
Yeah.
We're concatenate.
Okay, hi, my tongue broke.
Yeah.
We're going to concatenate to the end of that.
This is something that's very cool. There's a static function in the WX string class that allows us to do something like printf, which allows us to take, say, an integer, a float, and store it into a string.
Right.
Which is very, very convenient for those of you that have had to use things like a to I or those cryptic functions. Well, they're not cryptic, but they're kind of a pain to use sometimes. So by simply passing it %d, this means that I'm going to pass it a variable, and it's going to store it in this location, and then everything's going to be cool. So we'll say player get lives.
We're using some old functionality there.
Yep. And let's just copy and paste this 3 times. And we're going to also have our info level and our info enemies. So the number of enemies that we have, so num enemies. Just to make it kind of clear. Here, we're just going to specify which level we're currently at. This one, which enemy we're currently at. And so this one we're looking for, what current level are we at? Well, Buzz, we created a variable that will tell us that.
Yes, we did. Current level.
And for this one, how many enemies? Well, there's a function.
That's called
num enemies.
Num enemies.
And that's it.
Num.
Anemones. So inside of here now we do have the strings.
Right, but we need to update.
We need to update the controls.
That's right.
So let's go ahead and say st player lives, and let's set the label
to what we stored in info lives.
Exactly. And I'm going to copy and paste because I'm getting lazy.
I don't blame you.
So this one is going to be set current level. This one's going to be
set num enemies.
Num enemies.
There we go.
And for this one, we want to get the info for the level.
Info underscore num enemies.
Info number underscore num enemies. And that's it. So we've updated the information. Now we need to check the different game states that are possible. Are there no enemies in the level? If all enemies have been killed, that means we need to, advance to the new level.
That's right. So the first thing we probably want to do is, we need to check, of course.
Right.
And then
we need to check the number of enemies that we have.
See if it's equal to 0.
Right. If there's no enemies left in the level, then
let's go ahead and stop our timer.
Yeah, we basically do, just to kind of throw this back at you guys, what we did in OnNew, let me just scroll back up here. You notice that we stop the timer, and then we create a new player. But in this case, are we going to create a new player?
No, we've got our player.
Because we want to just advance this player to a new level. So if we come back down here, we're going to stop the timer. So stop the timer. just kind of thought I'd throw you guys back up there and see what we did before. We're going to increase the current level, so we've advanced a new level. And then we're going to start a new level, and it's going to be of type random new level. And then we're going to create some enemies, throw some enemies into the scene.
Well, then we're going to start increasing the number of enemies.
Right. Before it was always 3 enemies.
Always 3,
and that's not very interesting. So what we're going to do is say int num enemies. Just create a local variable that we can use for a second here, and we're just going to create the number of. Okay.
Take whatever level we're currently on
and multiply that by 4, and that's how many enemies we have.
Right.
So for at level 2, we'll have 8 enemies.
That's right.
I know my math.
You're good.
I know.
But of course, we don't want to get it to where suddenly they have 60 enemies. That would just be mighty hard to play.
Yeah. So let's go ahead and say
cap it out.
If num enemies is greater than, say, 15, let's just set num enemies equal to 15.
So you can never get more than 15 enemies.
That's right. At
now
this
we
point,
need to add these guys in.
Precisely. So let's just go and add these guys in. And then let's set the player start. So set the player back to the beginning, wherever it may be. Now this is going to come in real handy when we actually load our own packages, since you'll be able to set where the player start is. So it'll work the same as with this. And then finally, let's actually begin the game again. So timer start and have the update time. So that covers this one case where we need to advance the level. Another case is, what if the player died? We want to have the game be over. So what we're going to do is a level num enemies. If the number of enemies is greater than 0, so there are still enemies in existence, and the player is no longer alive, so is alive is not true, then what we're going to do is very simple. We're going to set the game state equal to state game over. Game over. And then we're going to stop the timer. So simple as that. Otherwise, let's go ahead and just continue updating the level.
Right.
So just update. And last but not least, this is the update game function, so we want to make sure that update view is in fact called.
Right.
Now, that's pretty much all we need to do. Now, when is update game supposed to be called? Well, on the timer, because that's when it's supposed to be happening. So instead of having level update and update view, we now have an entire function dedicating to calculating all that information.
So just update the game.
So I'll just update the game, and let me just. That should be everything.
Cool.
So let's go ahead and rebuild this. Give it a second to link, and check it out. So
the right-hand side's empty.
The right-hand side is empty. If we go to File, New.
It just came to life. Lives are 3, levels at 1. Well,
and I died.
You died really fast.
So let me just create a new level.
There you go.
And as you can see, it's reset back. And if I kill one of the enemies, check it out. Enemies is now set to 2. And if I can actually win,
set to 1.
And 1 more to go.
Set to 0.
And check it out.
Look at that, level number 2 now.
And there's a lot of enemies.
There's 8 enemies.
So if I killed these guys, I would advance more until it gets too hard to play. So yeah, so now it's pretty much all created.
And notice there's only 4 enemies now, and it reflects that over on our low info panel. And die once, just to show lives dropping to 2. There.
So, and if I died again, now I'm just kind of running for my life.
Yes.
So I guess that's
beautiful. With that, that's really going to wrap up the lesson.
Yeah, definitely.
Let's go and exit out of this and jump back over to context.
And look, file, exit. Works. Oh, isn't that great?
So back to context. And we've really accomplished what we set out to do.
Yes, we did.
It's a basic state management system, but nonetheless, it is a state management system.
Right, and it can be built upon. This is the foundation.
That's right.
I kind of feel like some people think game development is so difficult. Well, if you understand the basics really well, this is really the basics right here.
Right.
And if you understand this really, really well, creating a more complex game is simply a matter of designing it, figuring out what you want in the game, and then just going out and programming it, implementing it.
That's it. Which, of course, planning is
planning
so important.
Is very, very important.
So we've declared our variables and constants needed for the state management system with our enums, and we prototyped our new necessary functions, start new level, update view, and update game. We then went in there and took care of adding start new level and update game just to the point so that we could test the game, make sure it did indeed work, and then we went back, enhanced our game logic with update game, making that kind of the heart at this point, and allowing us to advance levels, update our information over on the right-hand side, etc.
Yep.
And with that, that's going to wrap up this lesson. Thanks, everyone.